In this video, let's take a look at creating some boundary surfaces using our 2D sketch inputs. When we dealt with swept surfaces and loft surfaces, we had a very distinct set of inputs that we needed to follow. With a sweep, you need to have a profile and a path. With a loft, you need to go from one profile to another. Of course, you could have multiples of each. But when dealing with a boundary surface, you have a little bit more freedom when dealing with your inputs. Let's take a look at some of these inputs. When you open the boundary surface feature, you have a direction 1 curve and a direction 2 curve selection. For lack of better terms, we can think of these as our profiles and our paths or guide curves. So let's take a look at the sketches on our screen. For direction 1, we can go from sketch 1 to sketch 2. We can think of this as a loft going from one profile to the next. For direction 2 selection, we can grab sketch 3 and consider this a guide curve. So you'll notice that with each of these selections, you have a drop-down box that allows you to do things such as give it a direction vector, make it normal to profile. If we were selecting edges of a surface, we would have tangency and curvature options as well. The limitations to creating boundary surfaces are really only in the types of curves you use. So if we're trying to create a boundary surface that goes between these three profiles here, we would no longer be able to grab sketch 3 as a direction 2 option because it no longer intersects all of our sections. So if you're trying to use direction 1 and direction 2 in conjunction, you need to make sure that there's intersection points on all of the curves you're trying to use. Some of the freedom involved with a boundary surface is the ability to use one of each curve or multiples of each curve. For instance, we can use direction 1 as sketch 3 and direction 2 as sketch 1. And this would be a complete input for our boundary surface. We could also add multiples such as grabbing sketch 2 for another direction 2. But again, we can't grab any extras if they no longer intersect these curves. Another stipulation which we must follow is you cannot go from an open curve to a closed curve. So for instance, we have the spline in our sketch 1, we have a circle up here, and we're no longer allowed to do this because it's considered a mixed case. You can do a boundary surface between closed profiles or open profiles, but you can't go between the two. So let's go ahead and just create a boundary surface going between these three and take a look at the results. So as you can see, our surface is created in 3D and we have a lot of curvature to it, all based on the 2D sketches we created. So this is a great way for you to create complicated surfaces with a varied type of input. You can use multiples of direction 1 or direction 2, grab surface edges or solid edges, and loft between closed profiles with each other or open profiles. One of the limitations with a boundary surface as opposed to a lofted surface is you don't have a centerline path option. When we dealt with a lofted surface, we could use the centerline path in addition to the guide curves. When you're using a boundary surface, you must intersect each curve. The center point will not count as an intersection because it's not actually intersecting any of the curved geometry.